we're going to talk about simple harmonic motion. Let's assume that there is a mass on the spring. And assume that the force on the mass is proportional to how stretched or compressed the spring is. So we get F equals to negative kx, where F is restoring force. K is the force constant. And x is the displacement. From physics, we know that F also equals to ma, where m is mass, a is acceleration, so by rearranging this equation, we get a equals to F over m, which is negative kx over m. And we also know that the first derivative of x is the velocity, and the second derivative of x is the acceleration. So we get second derivative of x equals to negative kx over m. By rearranging it, we get second derivative of x plus k over mx equals 0. Since k over m equals to omega squared, where omega is the angular frequency, so we get the second derivative of x plus omega squared x equals 0.
Okay, after we get the second order differential equation, this is the second order differential equation, then it can be solved by using a trial function. So we assume that the equation is of the form like x equals a multiply e to power number t for constant a and the number. So this is gonna be differential for twice. So this, it will be second derivative equals number squares multiply a multiply e to power number t, and we should know this should be substituted to this equation, and this also substituted to this. So it's gonna be number squares multiply a multiply e to power number t plus omega squared multiply a and multiply e to power number t equals 0. And then we can get the characteristic equation. It's gonna be number square to omega squared equals to 0. And the solution is clearly right. It's gonna be number equals positive and then positive I omega and negative I omega. Thus, the solution, yeah, we can get the complementary solution. complementary solution is x equals a multiply e to power I omega t plus b multiply e negative to power negative I omega t. Yes, where a and b are different constant. Then we can use the exponential representation of sine and cosines. It can be expressed as the x equals a prime multiply cosine omega t plus b prime sine omega t, right? So where a b also are different constant. Then we should know it's also equivalent to the simple harmonic equation. This x equals x0 cosine multiply cosine omega t plus this. Actually, I want to explain this. X0 is angular. No, it's not angular. It's the amplitude, yeah. And this is angular frequency. And the phi is gonna be initial phase. So the graph is gonna be like this. Sorry. It's gonna be a cosine graph like this, blah blah. Okay. Okay, that's all. Thank you.